Hi everyone, today we'll be looking at the quadratic formula. So here's today's FLT. Given an equation written in standard form, I will be able to solve for x by using the quadratic formula. So for some of you guys, this lesson might be more of a review, and for some of you guys, this might be brand new. Either way, hopefully by the end you have a better understanding of how to use the quadratic formula. So if you have an equation of the form ax squared plus bx plus c equals 0, and make sure the equation equals 0, then you can solve for x by using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I just added some colors so that you see where each part comes from. So the most important step I feel like for the quadratic formula is to correctly identify a, b, and c, and then correctly replacing that into the formula. So let's walk through some examples together. Solve for x using the quadratic formula. We have 2x squared minus 13x plus 20 equals 0. Our first step is to identify a, b, and c. So the equation should fit the form ax squared plus bx plus c equals 0. And let's see which numbers replace a, b, and c. Our a value for this equation is 2. So let me write this on the side. A equals 2. And then our b is negative 13. Make sure you include that negative. That's important. And then our c value is 20. So c equals 20. Now that we have a, b, and c, we're going to plug it into our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. And then all of this over 2a. So what I'm going to do is replace each letter, a, b, and c, by the actual numbers. So I'm going to have, let's see, negative 13 plus or minus the square root of, so negative 13 squared minus 4 times 2 times 20, and then all of this over 2 times 2. And I usually like to stop here once to make sure I correctly replaced all the numbers. Especially when I have negatives, sometimes I forget to write it down, so I make sure to go back and make sure I write down the formula correctly. So here our a value is 2, b is negative 13, and c is 20. And from here, I'm going to start simplifying. So let's see. I'm just going to write it up here so that it doesn't become a mess. So negative of negative 13 is just 13. Negative 13 squared is positive 169. And then, let's see, negative 4 times 2 times 20 that will be negative 160. And also 2 times 2 is 4. So I'm just breaking down and simplifying like the little parts of the formula. So I have 13 plus or minus the square root of 169 minus 160 all over 4. Let's look at inside the square root. 169 minus 160 is 9. So I'm going to find the square root of 9. Everything else I just leave the same for now. Okay, square root of 9 is 3. So I have 13 plus or minus 3 over 4. And since I have a plus or minus, that means I'm going to have two potential solutions for x. So let me erase all of this and go on to like the next part. Go ahead and pause the video if you would like to review the steps up to here. So I have two potential solutions for x. One of them is x equals 13 plus 3 over 4. And my other potential solution is x equals 13 minus 3 over 4. And that's because the quadratic formula says plus or minus. So let's simplify each one. I'm going to start off with this first one. 13 plus 3 equals 16. So I have 16 over 4, which then simplifies to 4. And on the right side, 13 minus 3 equals 10. So I'll have 10 over 4. And I'm going to simplify this by dividing the numerator and denominator by 2. And I get 5 over 2. And here I'll leave it as a fraction, but you can also write it as a decimal 2.5. So I have two solutions for x. X equals, and I'm going to use these brackets, 4 or 5 over 2. We use the quadratic formula to find the two potential solutions for x. Let's do another example together. So we're going to solve for x using the quadratic formula for the equation 4x squared plus 15x plus 3 equals 0. Like earlier, first we're going to identify a, b, and c for this equation. So it should match ax squared plus bx plus c equals 0. And so what numbers replace a, b, and c? A equals 4 and b equals 15 and c equals 3. And then we're going to plug this into the quadratic formula to find x. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then here's the color coding, so you can see where a, b, and c are in the formula. And so let's replace these with the numbers we found for this particular equation. We have negative 15 plus or minus the square root of 15 squared minus 4 times, 4 times 3, and then all of this over 2a, so 2 times 4. So for this problem, our a value is 4, b equals 15, and c equals 3. All right, so let's simplify this. I'm just going to jot it in the corner again. So first of all, let's see. Negative 15 is as is. Let's see. 15 squared is 225. And then negative 4 times 4 times 3 equals, let's see, what does it equal? Go ahead and use your calculator if you'd like. It equals negative 48. And also, looking at the denominator, 2 times 4 equals 8. So I have negative 15 plus or minus the square root of, so I found that it's 225 minus 48 all over 8. We're going to simplify what's inside the square root. So we have negative 15 plus or minus the square root of 177 over 8. Again, since we have this plus or minus, we have two potential solutions for x. So we either have x equals negative 15 plus the square root of 177 over 8, or x equals negative 15 minus the square root of 177 all over 8. And what you can do here is either use the calculator for the entire problem, but in that case, I just want you guys to be careful of how you guys type it into the calculator, or we'll just take it step by step and kind of round as we go. The square root of 177 isn't exact, so I have to round. It's approximately negative 15 plus 13.30 over 8. Next, I'm going to add negative 15 plus 13.30. So x is approximately negative 1.7 over 8. So x is around negative 0.2. Not exactly, but very close to negative 0.2. Now let's look at the other option. Again, it's going to be an approximate answer, negative 15 minus around 13.30 all over 8. So that's negative 28.30 over 8. So x is approximately 3.5. So we found the two potential solutions for x. So we have x equals either negative 0.2 or 3.5. And here I had to round since we couldn't find an exact square root. But again, I have these two potential solutions for x. Let's do one more example together. And one thing I want you guys to note here is that we don't have to always use the quadratic formula if the equation is factorable. So if you can use exhaustion to factor the equation, then you don't have to use the quadratic formula. But not all equations are neatly factorable, and in that case, we have to use this, the quadratic formula. So for this example, we have x squared minus 12x minus 9 equals 0. So we have ax squared plus bx plus c equals 0. Let's identify a, b, and c. Oh yeah, and right here there's technically an invisible 1. So our a value is this invisible 1. A equals 1. Our b value is negative 12. Be careful about the negative. And our c value is negative 9. So c equals negative 9, and let's plug these into the formula. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's replace it with numbers. So we're going to have that x equals negative 12, so double negative, plus or minus the square root of negative 12 squared minus 4 times 1 times negative 9. And then in the denominator, we have 2 times 1. So here, negative of negative 12 is positive 12. Then negative 12 squared is positive 144. The negative 4 times 1 times negative 9 is positive 36. Also, 2 times 1 is just 2. So we have x equals 12 plus or minus the square root of 144 plus 36. And then in the denominator, we just have 2. So looking inside the square root, what's 144 plus 36? That's 180. So I have 12 plus or minus the square root of 180 all over 2. And since it's a plus or minus, again, there are two potential solutions for x. X equals 12 plus the square root of 180 over 2, or x equals 12 minus the square root of 180 over 2. So here again, the square root of 180 isn't going to be an exact number, so we're going to round. So we have approximately, for the first option, 12 plus 13.42 over 2, which is approximately 25.42 over 2. So for our first potential solution, x is approximately 12.7. For the right, so for the second potential solution, we have that x is somewhere around 12 minus 13.42 over 2, which would be negative 1.42 over 2. And so negative 1.42 divided by 2 is about negative 0.7. So x is either 12.7 or negative 0.7. And these aren't exact answers. Again, they're rounded here. But yeah, we use the quadratic formula to solve for x. Please try this example on Edpuzzle. Solve for x by using the quadratic formula for the equation 4x squared plus 8x minus 5 equals 0. If we have an equation of the form ax squared plus bx plus c equals 0, we can use the quadratic formula to solve for x. And here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Every time I say b squared, it reminds me of be there or b square. Goodbye.